in 4.2, we are going to talk about the exponential function. So the natural exponential function is something you might remember from a previous class. That is going to have e in it. And we are going to graph these functions today, and we are going to solve real-world problems with the exponential models. So the natural exponential function is f of x equals e to the x power. We are going to draw a graph of that, of the parent function. We're just going to do like a little rough sketch of it. So when you are finding values for a graph, remember how you can plug in any values for x? If you rate something to the 0 power, what is anything to the 0 power? 1. So when you plug in 0, you're going to get 1. That's going to be your intercept. So that's what we're going to put on our graph. And then just like yesterday, our domain is going to be all real numbers. We will write that down as well. So 0, 1 is going to be a point. Another point would be 1. And then you have, if you plug in 1, the value of e, do you guys remember what it is approximately? About 2.7. And then it's going to get closer and closer to your line. So remember, e is an irrational number. Okay, what we're going to use on our calculator is this e to the x button. So if you were to do e to the first power, okay, that would give you another point on your graph. And then you are going to have an asymptote at y equals 0. So it's getting closer and closer to y equals 0. So a lot of the stuff we're doing at the start is strongly related to what we did yesterday. Your domain is all real numbers because there's no restrictions. You don't have any fractions. You don't have any roots you need to worry about. And then for your range, you're going to do the lowest y value, which is 0, to the highest y value, which in this case would be infinity. The horizontal asymptote is y is equal to 0. And then we already found our y-intercept. When we plugged in 0, we got 1 as our output. Okay, so these are key values that we are going to want to include on our graph and that we are going to look at while we graph. So we are going to sketch the graph of each function, and we are going to state the domain, range, and asymptote. On your notes and on your quiz, you are going to be expected to do a table with at least 4 points. When you are graphing on your homework, as long as you are putting the specific points on your graph and you are labeling your graph, you don't have to write out the table. You can use your graphing calculator and use those points from that. Okay, but you are going to have to write it out on your quiz, and we are going to write it out here. So we're going to go to y equals, we're going to do negative e to the x power. Okay, so I want you to go ahead and graph that, and then we're going to look at the values on the table to determine what a good scale should be. So on your quiz, you are going to have to use the TI-84 or just any graphing calculator. Doesn't have to be the 84. Okay, so if you guys need to borrow one for today, there is a TI-84 website that you can use to practice that brings the calculator up for you. Okay, so in my standard window here, this 10 by 10 is going to be a great window. Let's look at our table. So at 0, I'm at negative 1. We do want to look at that intercept there. Oh, my table set is a little bit different. So I'm going to make sure it's good. All right, so at 0, I have negative 1. At 1, I'm at negative 2.7. At 2, I'm at negative 7.4. And then this one's kind of large, so let's see what's happening on this side. And like I said, you only need to write down 3 for this, or sorry, 4 for this. You want enough so that you can see your curve. Okay, so on my x's, I'm going to go by 1s. On my y's, I'm going to go by 2 so that I can fit all of those in there. Okay, so 2, 4, 6, 8, negative 10. All right, and then we are going to graph. Okay, so I have 0, negative 1. So if I'm going by 2s, it's halfway. At 1, I'm at negative 2.7, so that's almost to 3. And then at 2, I'm at 7.4, so about here. And then you can see that the values are getting closer and closer to what? When we look at our table, we can see they're getting closer and closer to 0. Okay, so I'm going to curve that. And did I put my... So at 2, 2, 4, 6, and then here's my 7. So I just need to adjust that. Okay, so you do want that curve. I'm just going to fix this. And then we're also going to put in our asymptote. I like using the highlighter when it's on an axis that's already drawn for you so you can see it. And then we are going to label that. Y equals 0. If you scroll on here, you're going to see all those values are getting closer and closer to 0, which is something we experienced with the other exponential functions. So you have your horizontal asymptote, you have your domain, negative infinity to infinity, okay, and then your range always goes from the lowest y value, okay, to the highest y value. Okay, so I want you guys to take a moment, write that down. All right, and then what do we get for our lowest y value here? The lowest y value. Yep, negative infinity. And then the highest y value? Yep. So because that's a horizontal asymptote, we talked before about how if it's an exponential function, it's not going to cross it. It's going to be the same thing here. Okay, this is an exponential function, so it's not going to cross it. Okay, so then for part B, we are going to consult our graph and consult our table. Okay, from yesterday's, do you guys remember how you can just look at the function and you can tell what the asymptote is? Do you guys remember that? What is the horizontal asymptote going to be for this without even looking at the values? Yeah, what is it? -2. Because if you have your equation, it's whatever's added or subtracted. Okay, and then we know our domain is all real numbers. And then we're going to pick some values from our graph. So again, this 10 by 10 looks pretty good. Let's see if we can do the x's by 1s and the y's by 2s again. So here I can see it's getting closer and closer to -2. It's not exactly 2. Just so you know, sometimes this is just going to round it. If you highlight it, you can see the actual decimal. So we just have to be smarter than that technology, right? This doesn't mean that it's inclusive. It's still going to be a soft bracket. All right, and then I usually just pick a value where I can see it's just getting closer and closer to -2. So maybe I would do -2 and -2.05. 1, -3 would be helpful. 2, negative 4.7, and then 3, negative 9.4. Okay, so again, I can do my x's by 1, I can do my y's by 2. All right, so at negative 2, I'm at negative 2.05, so it's a little bit above that. Okay, at 1, I'm at negative 3. At 2, I'm at 4.7, so almost at 5. And 3, I'm a little bit past my 9 there. So once I put those points on there, and I know they're really light, that's because I like to curve this. I would do this in pencil first. I'm just doing this color so you guys can see this. Okay, and you're connecting this with a curve. And then you always want to put in your horizontal asymptote, and we're going to label it. Okay, so this would be at y equals negative 2. Okay, again, your range is going to go down to negative infinity, and then the highest value would be negative 2. Okay, so when you're doing your graphs, if you were just like writing flashes and not labeling them, that would not be full credit on your homework, okay? And same thing on the test. Hopefully that's obvious. Okay, so you do have to put your points on your test. You will make a table as well. All right, now we are going to get into real-world problems. Everybody's favorite thing to talk about, infectious diseases begin to spread in a small city where the population is 8,000, and after 2 days, the number of persons who have succumbed to this virus is modeled by the following. This is asking you how many infected people are there initially. Whenever you're finding the initial value, do you guys know what you have to plug in to find that? Some of you have taken physics, right? And when you're in physics, you find the initial velocity. What do you plug in to find it? 0. You always plug in 0, right? Same thing here. Okay, so we're going to plug in our t value is 0. Okay, so your value for v, we can do this without our calculator. So if you raise something to the 0 power, remember what we just talked about? If I were to plug in 0 here, what's 0 times negative 0.95? 0. What's e to the 0? 1. 1 times this is 1596. What's 1596 plus 4? What's 1596 plus 4? 1,600, right? Because if it's 4, that just goes up to 600. And then we can reduce. So if you divide by 100, you just have 80 divided by 16. What's that going to be? 80 divided by 16. Sorry, I brought mine over there. Okay, so it'll be 5 people. Okay, now when you're determining the number of people after 1 day, 2 days, 6 days, of course you can plug these in. You can plug in 1, you can plug in 2, you can plug in 6, but may I suggest we use a table. It'll also help us with part C. So you're determining the number of infected people, so we're going to round to the nearest person. If it doesn't tell you what to round to, you can decide, okay, if it's something that warrants a whole number, I would recommend that. And then we are going to use our table and our rounding rules. Okay, so you can use your table. And when I say use your rounding rules, that's if it's 0.5 or up, you're going to round up. 0.4, you just keep it the same. All right, so when you're ready, we're going to plug this into our y equals in our graphing calculator. We have 8,000 divided by 4 plus 1596 e to the negative 0.95 x. Okay, and you do have to put your parentheses in the denominator. And then I want you to go to your table and then find what happens at 1, 2, and 6.
Sorry for the interruption, staff and students. I just need to have a reminder for my students. Stay in the hallway, coming back from lunch, being lunch. There were some students.
Okay, so for these values, like I said, it's really quick to use your table here. So we are going to go to our table, okay, and then at 1, if you click on it, you can see the whole decimal. You don't really need the whole decimal because we can round to the nearest whole number without it, but this is going to be 13 people. Okay, and then when you plug in 2, you're going to round to 33 people. And did you guys have enough time to do the 6th one? Okay, so you should have got 857 people. Okay, and then for C, it says roughly how many people eventually get infected. The textbook is going to tell you to look at the graph for very large values. I think it's easier to look at the table because you can just go to your table set, okay, and then type in a very large X value. Sometimes you can even just scroll and find it. So if you were to just keep scrolling down, eventually you're going to get to a number where all the values are going to be that number. So do you guys see what it is for this one? Yeah, they're all getting closer to what? 2,000, okay? You could also go to your table set, and usually I would plug in something like 500. I'd plug in something large, okay? And then if that wasn't big enough for all of them to be the same, okay, then I would keep going. So eventually it's going to be 2,000 people. What I like about these real world models is it is going to taper off just like it would in the real world. When you have a disease, that number is going to level off because people are either going to succumb to the disease or there's going to be a cure and they're going to get better, right? So if you check out your graph here, we're going to keep in mind that this is 2,000, so I'm going to adjust my window. So maybe my max value, I want to see what's happening out of 100, and then I know it has to be at least 2,000, so maybe I'll go to 3,000, make it by 100 so we can see. Okay, so it's going to go up exponentially, and then it is going to level off there. Okay? All right, now we're going to talk about this skydiver. This very brave person who's decided to jump out of a plane here. Has an air resistance they experience that's proportional to the velocity, and the constant of proportionality is 0.2. It can be shown that the downward velocity of the skydiver at a time t is given by this equation where t is measured in seconds and v of t is measured in feet per second. So when we have these, we are going to make sure we include our units. Okay, so our v of t here is 80 multiplied by the quantity 1 minus e to the power of negative 0.2t. The first thing we're going to do is find the initial velocity. Okay, so even when you're finding the initial velocity, if you wanted to verify that with your table, you could. Keep in mind, this is something you can do without your calculator because we know what happens when we raise a power to 0. So if I do 0 times negative 0.2, this is e to the 0. E to the 0 is 1. 1 minus 1 is 0. 0 times 80 is 0. Okay, so it does make sense that the initial value is 0 feet per second, okay, because they aren't falling yet. Okay, so this is just going to be the start. And then we have to find this after 5 seconds and 10 seconds. Okay, so let's try that table technique where you're going to find V of 5 and V of 10. So I'm just going to give you a moment now to plug that in. Your graphing calculator. And use your table feature. And then you guys can find your V of 5 and your V of 10 using that. And then it does say to round to the nearest 10th. All right, so then when you guys investigated in your table, if you want, you could start at 5 and go by 5s when you're looking at your table. So you have the 50.57, so this is going to be 50.6, and then what's your units for this? The velocity is measured in what? V of t is measured in feet per second, so you're going to include that with your story problem. Okay, and then I'm going by 5s. So again, we're following our normal rounding rules. So if it's 0.17, that 0.1 gets rounded up to 2, okay, feet per second. Okay, and then for part C, I really should have put a little grid on there for you, but I didn't. So we're going to make the grid ourselves. When you are drawing a graph for the velocity, we only have to worry about the positive values, the positive time, and the positive velocity. Okay, and when we do this, we are going to label the axes. Okay, again, you do need to label your units. So I'm not making you write out a table because you're going to have specific points that you're going to use from the table on your calculator. All right, so 5, 10, oh, here, let's look and see. So if I keep scrolling, I can see it's getting closer and closer to 80. So I decided to go by 5s because that's going to get me really close to 80. So 5, 10, 15, 20, 25, 30, 35, 40. Okay, that's going to be enough to see my pattern. And then my velocity is measured in feet per second. That's your V of t. Okay, so I have to go up to 80, so maybe I would go by 10s. 10, 20, 30, 40, 50, 60, 70, 80. You don't have to go past that. All right, and then let's go ahead and use some of our points here. Now you've already found some points. You found the initial value, 0, 0. This is a point. When you plug in 5, your output is 50.6. So let's graph that. That's really close to 50. Okay, when you plug in 10, you're almost to 70. Okay, and then you can find some other ones on your graph. A lot of these are going to be so close to 80 that you're barely going to be able to decipher it. But again, you want to have that curve. So you're showing that these points are getting closer and closer, and they're going to level off at 8. Yeah, so when you're looking at the graph for this, okay, set this up according to what we just plotted. So you can do your min at 0, your max, we can go out to 50, go by 5s. Here we're at 0. I like to show it's above 80 so you can see that. And then I went by 10s. Okay, that's going to give you a good picture of what's happening. If you don't have a good window, then it's going to look skewed. That's why we're using the table to help us. Okay, so we got to have those specific points in there. All right, and then for part D, we are going to find the maximum velocity. It tells us the maximum velocity of a following object with the wind resistance is called the terminal velocity. And then from our graph in part C, we are going to find the terminal velocity of the skydiver. And then we're going to explain how we found our answer. Okay, so we could also see from the table what our terminal velocity was. Okay, so the terminal velocity is what it approaches. So based on what we saw in our table and on our graph, it's going to be approaching 80 feet per second. Okay, and then we're just going to explain how we found that. Okay, so what we did is we looked at those y values. Okay, we examined the y values. For large x values, and saw they converged to 80 feet per second. Okay, so you have your explanation and your answer. And then the last thing we're going to cover today is going to be about compound interest. So many of you are going to remember this formula, the continuously compound interest. The formula is called PERT for short, PE to the RT. Okay, so your PERT formula is when interest is compounded continuously. So you still have your principal amount after T years. This is your amount after T years, your principal amount, and then the interest rate, still a percent, expressed as a decimal, and then T is the number of years. Okay, so similar variables from yesterday, but we can use E if it's compounded continuously. When something's compounded continuously, it means that interest is compounded at every instant. Okay, in section 4.1, if you've completed your homework practice, we saw the interest paid is going to increase as the number of compounding periods increases. Okay, so the interest increases if the number of compounding periods increases. So if you have all the same conditions, okay, and you get to choose whether it's quarterly or monthly, you would want to choose monthly because it gets compounded more. Okay, that means if you have the same conditions, that continuously would always be the best, but we're going to explore some different situations and see how much better it is. Okay, and then we're going to do some with different conditions, and in that case, it may not be the best. So for example, 1, you have a sum of $2,000 put in an IRA that earns 7% per year. you have to find the amount after 10 years if the interest is compounding continuously. That's what we're doing for part A. For part B, we're going to find the amount if the interest is compounded hourly. So here it's compounded continuously. Here it's compounded hourly. That's going to let you know which equation you have to use. On your assessment, you will be provided both of the formulas. You just have to know which situation you are going to use what. So the 2,000 is your principal value. Your rate is 0.07. You're going to have to find your A value, and if it's continuous, you have to know that you're using your PERT equation. Okay, so it's 2,000 e to the power of 0.07 times t. In this case, your t is 10 years. Okay, so I want you to see if you can plug that in and then round it to the nearest hundredth. And then I want you to set up part B. So if it is hourly, just remember you have to use the equation from yesterday. And I'll write that down for you so that you can plug those into the correct spot. All right, so when you round it to the nearest cent, what'd you get? So look at if you're rounding to the second place, look at the number after, right? So it was 0.505, so what do we round to? Yeah, 5.1. Okay, so it won't be 50 cents because of that 5 after it, okay? All right, and then if you're compounding hourly, so maybe some of you started this one, the 2,000. Are you guys able to find the value of n without me? N times t, and we're going to keep the same t. So if it's hourly, you have to find how many hours are in a year. How can we do that? Yep, how many hours in a year? So 24 hours. Remember doing this in chemistry. There's 24 hours in one day. There's 365 days in 1 year. And then that tells you hours per year. Yeah, you remember or no? Okay. All right, so then you get 8,760. So that's what's going to go in for n. Okay, this is your value for n. All right, and then you can compute this all at one time. If you're doing that, you just watch out for your parentheses, your order of operations, depending on what calculator you have. Okay, and then $4,027.49. So Remember we said that, yeah, continuously is going to be better under the same conditions. Okay, but really, how much better is it? Yeah, 2 cents. This one isn't going to make it or break it if that's what it is. Okay, sometimes though, those little values add up over time. And there is one of your homework problems that explores this, okay, in 4.1. So which one will give you a better return? Okay, compounding continuously. Okay, or you can say RA will earn 2 cents more. Giving you a better return on your investment. Okay, so on your assessment and on your homework, you are going to be required to do some explanations. So make sure you're saying what is better by how much, okay, and then forming a complete sentence with that. All right, so now we are going to have a few different situations that we're going to compare. And this one's a little bit different. So I wrote out some steps to help you. So it says, which of the given interest rates and compounding periods would provide the best investment? Okay, and again, we're going to explain our findings. So when you're first reading through this, you're going to notice, all right, it gives me the rate as a percent. I'm going to change that to a decimal. You can always divide that by 100 if you're not sure, but 3.5% is just 0.035. You move your decimal places 2 to the left. Okay, and then if it's quarterly, your N value is 4. The 3 1/4% is 0.0325, and if it's monthly, there are 12 months in a year, or quarters in a year. So if it's quarterly or monthly, you are going to use this equation that we were introduced to yesterday. And then the 3% compounded continuously, you have your rate, but you aren't given your N value because you don't need it. You are going to do the PERT equation. Okay, now when you go to calculate this, you may notice when you start to plug things in, hey, I'm missing a few things. Okay, we don't have a time and we don't have a principal value. That means you can pick it. Okay, when you're doing it, it doesn't matter what you choose as long as it's consistent. For this example, I just chose we were going to use $100 and 1 year because I thought those would be pretty simple to calculate. So pick an investment in a period of time. We're going to use $100 in 1 year, and then we're going to calculate these investments. Okay, so your A value, your B, and your C are going to be you setting up your equations. Okay, so I want you to write down your setup, and then do your calculations, and then we'll compare them. check our setup. Okay, so we have 100, 1 plus 0.035 over 4, and then it's 4 times 1, or just 4 is fine. This would be 100, 1 plus 0.325 divided by 12 to the 12th power. And then the last one will be 100 e to the power of 0.03 times 1. All right, so for part A, we should have got $103.55. B is $103.30. And then C is $103.05. All right, so when you are writing out your explanation, you're going to say which one is the best return. So choice A, not as, fix that. Choice A is the best return. You earn blank more than choice B, blank more than choice C. Okay, so when you are laying those out, you're just going to say by how much. Okay, so choice A does give you the best. That is quarterly, but that is based on the percentages. Okay, you have 3.5%, and that was the best in this case. So if you compare these two, then choice B, it's going to be 25 cents more. You can either use the cent symbol, or I think some of you like to write it like this. Either one of those are fine for the money. Okay, and then when you compare it to choice C, it'll be 50 cents greater. Okay, so just make sure that you are finding those values. Okay, I'm going to put your homework up on the calendar so you can see our due dates and what's coming up ahead.